Hello everyone, thank you for attending this session. It's a pleasure to be here today. My name is Juliano Guiz. I'm a lead product manager at OpenText. In this session today, I will cover what Kubernetes can do for you, talk about our path to containerization, and provide a demo deploying OpenText Extended ECM on Azure Kubernetes Service. First of all, what is Kubernetes? Kubernetes is an open source system for container orchestration. And here is what Kubernetes can do for you. Deployment scheduling. It defines where my container should run. Scale my deployments up and down. Find where containers are running with the discovery capabilities. Distribute load across containers with load balancers. Provide storage to containers with persistent volumes, and track what is happening with our containers behind the scenes. Here we have a few Kubernetes concepts that I would like to review with you. Nodes, cluster, workloads, pods, persistent volumes, and service. Kubernetes nodes. A node is a worker machine for Kubernetes to distribute workloads. Usually that it's a VM. Kubernetes cluster. It's a managed group of nodes. That's the first step in a project, and Azure really makes it easy to set up. Kubernetes master nodes. It runs Kubernetes components to help control and manage the cluster, such scheduling, scaling, monitoring, its APIs, and much more. Kubernetes pods. This is the smallest base Kubernetes management unit. Kubernetes schedules a pod to run a workload on a node. In a workload, it's an application running on Kubernetes. Kubernetes service, it exposes pods as a network service. It could expose the service internally to allow communication between pods cluster, or it could be external communication to allow internet access to your application. Kubernetes also provides DNS, proxy, ingress, and load balancing. So let's take a look now on the OpenText Extended ECM path to containerization. First of all, what is Extended ECM? Just to provide an overview, OpenText Extended ECM connects content to digital business to accelerate productivity, improve governance, and drive digital transformation. Our latest release, CE, Cloud Edition, we define as a content management reborn cloud for a few reasons. First, we have cloud native applications leveraging technologies such Kubernetes, Docker, and Helm charts. Upgrades and scaling can be achieved in a fraction of time, and it can be deployed anywhere in the hyperscalers or in private clouds, and of course at the OpenText cloud. In this slide, we have the architecture diagram of a typical deployment of Extended ECM. Let's take a moment here and cover some of the concepts that we saw on the previous slides. Let's start with the Kubernetes cluster. As I mentioned, that's the first thing that should be set up in the project. This is where you are going to deploy your containers. You can create a cluster with multiple nodes as needed, include nodes that are located in multiple zones or regions for high availability. The second thing that I want to show here are the pods and workloads. As you can see here, we have multiple pods with workloads, for instance, for content server front-end and back-end. The viewing components, OpenText Direct Service, Archive Center. Next, I want to mention about the service. As you can see here, we have our pods exposed, or either to external or internal access. For instance, the content server front-end, the viewing, and the OpenText Direct Service, they are exposed externally, so users can access those applications directly. And we do have the content server backend and archive center service that do not allow external access. Right here in the middle of the architecture diagrams, we have the persistent volumes. The persistent volumes are entities that allow containers to store data. Containers, they may need to store data, for instance, configuration, application data. And here on the right, our containers are leveraging service from Azure, for instance, file storage, database, in the case Postgres, and object storage. But how can we simplify the deployment of all of this infrastructure? We follow 3 steps to simplify the deployment. Let's take a look. Number 1, deliver our product as Docker images. Second, leverage Helm chart to pack and distribute the configuration for our containers. And introduce deployment automation to avoid manual tasks during the deployment. Let's take a look in more detail on each of these steps. Docker containers. We are delivering Docker containers for all of our product family in respective components. For instance, Extended ECM document for SAP, Extended ECM platform, Extended ECM for Salesforce, SAP Office 365 for engineering, success factors, and Extended ECM for government. And of course, we also have a content suite platform. Helm chart. In the Helm charts, we have all necessary deployment definitions. For instance, container version to be deployed, resource to be allocated, such CPU, RAM, and how many instances to be deployed in our container, and many other configurations needed for your deployment. Here we have an example of a Helm chart install command to deploy Extended ECM. I'll talk more about it in the following demo. Once the Helm is installed, it can easily upgrade by just run a Helm upgrade command with the new container version that it's available. And the last step, we implement automation in our containers to deploy a fully configured solution out of the box. And here we have a few examples of tasks that we have automated in our deployment. For instance, to install content server configure the web server, apply license, import administration settings, application and security hardening, module installation, and so on. So across all the components, we have automation to connect those components and have they configured out of the box. Good, so we are ready now to see all of these concepts that we discussed in action. In the following demo, I want to show how you can leverage the Azure Container Registry to push your images, how to deploy your containers on Kubernetes Service, how to connect to an existing database created in Azure SQL for Postgres, and how to scale your deployment. In this demo, I want to show how to deploy Extended ECM Cloud Edition in Microsoft Azure Kubernetes Service, which is a new way of deploying our solution now using containers. Here in the screen, we are looking at Extended ECM deployment. And to better understand the concepts and how to deploy our solution, we have to look a little bit deeper into the architecture behind the scenes. The Extended ECM product has multiple components. And starting early this year, we delivered these components as Docker containers. In this architecture diagram, we can see all the components and respective containers that are part of the Extended ECM. For instance, Archive Center, OpenText Directory Service, Intelligent Viewing, which is a combination of multiple services, Content Server Backend, and Frontend. The first step is to pull these Docker images that are available in the OpenText Container Registry. You can access the registry using your OpenText MySupport portal credentials. Another artifact that we will need is the Extended ECM Helm chart, which is available in the OpenText MySupport portal under the Extended ECM download area. The Helm chart contains the Kubernetes manifest files, making it simple to package and deploy multiple components on Kubernetes, which is exactly the case of our Extended ECM solution. The Extended ECM Helm chart packages. First, all the components parameters, for example, the container version to be deployed, resources such as CPU and RAM to be used, and also parameters that are used to guide our deployment automation. Secondly, we have platform parameters. Those are definitions that are specific to the target Kubernetes platforms that you want to deploy. We could have Azure, AWS, Google, OpenShift, which we have recently released a preview, and of course the OpenText Cloud. Lastly, we have deployment sizing examples. They are useful if you want to use different deployment size across different deployments. For For your test, QA, or production environments, you may want to use different deployment size, so you can modify those files as needed. Let's go to the Azure Portal. Alright, so let's see how we can deploy Extended ECM on Azure Kubernetes Service. Let's access Azure Portal. I'm going to enter my credentials. Perfect. We are now at Microsoft Azure Portal. The first step is to push the Extended ECM containers to the local container registry. So Microsoft Azure, it does provide a container registry that you can push images. I do prefer to push my images to a local container registry, so I have all my container images locally available for my deployment. I have already pushed a few images here. For instance, if we look at the repositories, I have OpenText Archive Center, OpenText Content Server, and OpenText Directory Service. And let's see the version. Okay, I have pushed the OpenText Content Server version 21.1, which is good. Now, the next step is to create a Kubernetes, under the Kubernetes service, to create a cluster. I have created one already for this demo. You can define the location, the nodes that you want to use, the version of the Kubernetes you want to deploy. I'm going to post here a link with details how you can create a cluster under the Kubernetes service. But now that you have the Kubernetes cluster available to deploy our solutions, we can start to deploy the Helm chart from Extended ECM. The way I do that, I use this very useful Cloud Shell from Azure. Let me maximize here. I grab, as we saw before, the Helm chart from Extended ECM, and I upload here using this tool. And I have already uploaded and extracted here. I can take a look inside the folder, and I can show a few things here. The first are the platform files. So we do have configuration file for specific Kubernetes platforms. One of them is Azure here. So in this file we have parameters that are specific for this platform. I can show here the platform file for Azure. As you can see here in the header, we say platform specific settings for Azure platform. We have the command here and how you should install your Helm chart. You have to define a few things, the image source where we are pulling from your images. So in this case, I have from Azure Container Registry. As I mentioned, I like to have my images locally, available locally, so it makes faster, more reliable to deploy, and especially in the case you need to upgrade or restart or deployments, yeah, you always have a local repository available. And also here you define the hosts of the components that you are installing, for instance, Content Server, OTDS, Archive Center. So there are preparation steps that are available in your documentation to cover that, on how to create external IP in Azure and how to register your domain in the DNS. Good, I can go back now. If I go back here, and of course we have the values file. So this is where we have all the parameters for all the images that are necessary for Extended ECM. For instance, we have OpenText Content Server, we have the version that is going to be deployed, and the resources that are going to be used, such CPU, memory, and also the limits, how much you should use. So if you deploy, if I do run this command here, it's going to deploy my Helm chart using all the default parameters that we ship. So other than the parameters to install the Helm, I'm disable Archive Center, I'm using Content Store as the database. And since I have created a database in the Microsoft Azure Portal for Postgres, I'm going to leverage that database. So pretty much here I'm defining the host, the database port. What I'm doing here with these set commands, I'm overwriting those values those default values that are present in the Helm chart. So now I run this command, and what it's going to do is just deploy Extended ECM with the default parameters plus those parameters that I just defined in the command line. Once I run the Helm install command, I can check the deployment using kube control get pods. You can see here that the content server admin front end are being deployed. OpenText direct service is already deployed. So after a few minutes, we can check it again here. Great, I have now all the containers running. And also you can follow this from the UI, right? Let me leave here, I just minimize here. If I go back to Kubernetes Service, I can go to my cluster and I check the workloads, pods, and I'll filter by my default namespace. And here you can see that my pods are up and running. And not only that, but it's very interesting that we also create service, as I mentioned. Let me minimize here. And under service, if I go to my default namespace, I have all the service created for my containers. So I have for content server admin, which is the backend, the front end, and the OTDS. In the case of the content server admin, we define that it's only exposed for internal communication. The content server front end and the OpenText directory service, they are exposed for external access. And as part of the deployment, we also create all the persisted volumes that are needed. So all containers, they do use persisted volumes. In this case here, for application data, for configuration, for content server applications that deploy logs and so on, we create persisted volumes as needed. So the containers, they can be redeployed in the case of failure, and the persisted data there is needed, that it's not leaving the database, it's stored here in these persisted volumes. Now what I can show that it's very exciting is how to scale these containers. This can be achieved from the UI or from the command line. I'm going to the command line here to show how it's easy. We can go now in the UI or even come here and see the pods. You can see that a new front end deployment was triggered. So the container is being created. And what's interesting is that if I go here in the UI, you also reflect my scaling. So here I go back to my cluster, my workloads. Let's take a look on the stateful sites. Let me minimize this window here. And you can see now that the second front end is being deployed. There is a message here saying that it's not ready. So the load balance is not including the second front end to accept requests. You wait for this container to be available to accept requests. If I go here into my front end, you can see that I have two pods. Oh, it's telling me now that it's ready. So if I refresh, yeah, it's ready. So I can access my application. Now I have my application up and running, and with two front ends behind the scene accepting requests. In the same way, I can go back there. Let's say you don't want to use the two front ends that you have available. You can always go back and scale down your deployment. The same way, if I go back here and check my front end, let's refresh. You see that the front end only now have one container available. That's very exciting. So it's very easy. If there is the need in a specific time of year that you wanted to scale up, you can easily scale up your container as needed. You can scale down. So that's it for my demo. I really hope that you enjoyed the demo. At least we are very excited to be using Kubernetes, and especially with Microsoft Azure, with the Kubernetes service that Microsoft Azure provides. It just makes everything much, much easier. It's a completely new paradigm on how to deploy our applications, and we are very happy that we are in this path. Thanks so much everyone and have a nice day. Thanks for joining this session.